Hello and welcome to this video about remote peering. I'm Wolfgang Tremmel and I run the DE-CIX Academy. Remote peering, why should you do that? And why can you use DE-CIX features to configure it safely so that it really does what you want? First, with remote peering, you get peers you do not get at your home IXP. Also, you do not need to run your own connectivity to the remote IXP. DE-CIX does that for you. We simply deliver the remote IXP as another VLAN ID on your DE-CIX access port. The connectivity is monitored and also maintained by DE-CIX. You don't have to take care about that. We do it for you. Also, you can simply book the bandwidth you need via the DE-CIX portal. If you need more, simply go to the DE-CIX portal and increase the bandwidth. And let's have a look how remote peering can work for you. I'm setting up an example network. I am AS64500, located in Europe. I have, this is me here. I have two transit providers, also in Europe, AS65001 and AS65002. For redundancy, it's always useful to have two transit providers. And I am located in Frankfurt and I also peer here at DE-CIX. But I also do remote peering at DE-CIX New York. So I have two internet exchanges connected to my network, DE-CIX Frankfurt and DE-CIX New York. And this is one of my peers, AS65501, also European network. They also peer in Frankfurt and also peer remotely in New York. So this is the setup we are using here to show you. And just to add some more, there is another peer I'm adding, AS65502. That's a North American network, and they are only peering at DE-CIX New York. So let's have a look what happens if I receive BGP prefixes. AS65501 is announcing one IPv6 prefix, and I receive that via DE-CIX Frankfurt with only them in the AS path, and I also receive it via my transit providers. Here the AS part is slightly longer. The transit provider is added to the path. And I also receive it via DE-CIX New York. And also here I have an AS path length of 1, so also a short AS path. To summarize, I receive it 3 times. I skip the second transit provider. I have a longer AS path via my transit and 2 AS paths with the length of 1 via both my peerings in Frankfurt and New York. And what we want, of course, we want to go the traffic via Frankfurt, via DE-CIX Frankfurt. So we want to have the first one, the first announcement we receive the best. And in case of an outage, we want to use our transit provider. We do not want to use DE-CIX New York as a backup, because that would mean the traffic crosses the Atlantic twice. So this is what we do not want to use. So what happens if DE-CIX Frankfurt fails? Let's have a look at the BGP best path selection algorithm. We have here a parameter called local preference, and local preference is a parameter you are setting actively in your configuration, and with that you can prefer certain network exits over others. So we are setting now a local preference of 10 for our transit providers. We do not want to have them preferred. We are setting a high local preference of 10,000 to DE-CIX Frankfurt, and we're setting a medium local preference of 5,000 for DE-CIX New York. And now let's apply this local preference to our 3 announcements. And we see the preference is now, the first one is via Frankfurt, the second one is via New York, and the third one is via transit. The AS path length is now no longer an issue because the decision where to make the routing decision is higher at local preference. The router only looks at the local preference value. And this is not what we want, because we do not want to use DE-CIX New York as a backup. And that would happen with this kind of setup. Now let's swap local preference. Let's say the transit providers are now the second best and DE-CIX New York is the third best. What would happen? Since we receive everything, the whole internet routing table from our transit providers with a higher local preference, we would never use DE-CIX New York, because all the prefixes we get in New York, of course, we also get via our transit providers. So this is also not an option, setting the transit providers to a medium value and setting New York to a low value. In simple words, using local preference as a method to avoid crossing the Atlantic twice, this doesn't work. How to solve that? What do we want? Let's write it out again. We want to prefer local peers, Frankfurt peers. We do not want to send traffic to local peers via a remote IXP. Traffic to another provider in Europe should never go via the US. And we want to use our transit provider if my local peering goes away. How to solve that in a scalable way? Scalable means you do not want to adjust your solution for each and every network change. Next idea is to use MED and the BGP best pass MED always, or something similar, for a second-rate value after DAS pass lengths. MED usually is only compared for prefixes with the same next hop AS, but we can switch that off. If you enable MED always compare, so switching that off, and want MED for all your prefixes you receive, you have to set the MED value on your side on all connections for all received prefixes and for all peers. That's the downside of that, but you only have to do that once and you keep it in your configuration, and everything else happens automatically when you receive prefixes. So let's have a look at our network plan, how that would work. So we are now setting MED values, and we want the decision to be made after DAS pass lengths. So the first thing we do is we set local preference to the same value everywhere. We just set it to 1000 on all our peering points and on our transit providers. So now we are using MED. We are setting MED to 50 in Europe, and we are setting MED to 5000 in the US. So this is the values we are getting. The decision is not made at the local preference level, but the decision is made at the AS pass lengths again. So MED is after the AS pass lengths, so we make the decision at the AS pass lengths, and we still prefer the New York peering if the Frankfurt peering goes away. So again, just using MED doesn't work. What now? Well, read the documentation about Internet exchange points. What we want, let's phrase it out again. We want to receive and accept no prefixes from remote peers at the remote IXP. So in New York, I only want New York prefixes. I don't want prefixes someone from Frankfurt announces remotely in New York. And also, we do not want to announce our prefixes to the remote peers at the remote IXP. At the remote IXP, we only want peers local to that IXP, or perhaps also to the area of the IXP. So have a look at the route server guide on the DE-CIX website. DE-CIX uses BGP communities to tag, to mark prefixes. And you can filter these communities for continent, country, metro area, or even edge device. So also be aware of the limitation. Of course, that only works if DE-CIX knows that these peers are remote. So if they are connected via remote peering, like you are, we know about it and we tag the prefixes. If they run their own circuit from Europe to the remote IXP, it looks for us like they are local. So be aware of that. But even with that limitation, it's a pretty good way to configure your routers. So have a look at the BGP communities. In DE-CIX New York, like we only want to have prefixes from the United States. And for that, we are using this community 63034. That's the AS number of the route server in New York, 1913 and 840. And if that looks too cryptic, the first number is the AS number of the New York route server. The second number means country-based origin. And the third number means United States. And you do not have to remember all that. You can look it up. Just have a look at the route server guide. And the 840 is actually a standard for expressing countries in a numerical format. If you want to have in Frankfurt only Frankfurt prefixes, you're doing that with that community 6695. That's the AS number of DE-CIX Frankfurt. 1912. That means metro-based origin, not even Germany, but a metro-based like Frankfurt. And 0, that's our own DE-CIX, that's the own numbering for Frankfurt. We have a number for each of the metro areas we are in, and you can look that up on the website. So this is our solution for sending traffic. We are using filters based on BGP communities to only accept certain prefixes. What about receiving traffic? Receiving traffic means not announcing our prefixes to remote peers, only to peers local to that exchange. Peers only send you traffic if they receive your prefixes, so you must instruct the route server to not announce your prefixes to remote peers. And also this can be done by BGP communities, and we call these communities here action communities because they command the route server to do certain things. Well, there are many options to do that. For our case, there is a shortcut, and that is simply 65200 65202, and that means redistribute to local peers only. And simply set that, and remote peers do not get your prefixes. So, to summarize, how to configure remote peering. Use the DE-CIX route servers. Announce your prefixes with BGP communities tagged announce only locally. Have a look at our website how to do that. Only accept New York local prefixes by filtering. You can use, like for example, a filter to only accept New York prefixes, or you can also say, okay, I want United States prefixes, or I want North America prefixes. Simply, that's up to your need. Have a look at the DE-CIX route server guide, how to configure that. And let's have a look at the map, how that now works. So again, our example network, I'm announcing a prefix with the community announce locally only, and that prefix now gets announced to our North American only network, which is local to that IXP because the filter lets it through, and it does not get announced to other European networks who are also connected to New York via remote peering. The route server sees the community and does not announce it to other European networks. On the other way, if a North American network announces a prefix to the New York route server, the BGP community is added by the route server, and you can check in your router with a filter for the community and let it in. And if someone announces a prefix who is also located in Europe, the route server in New York also adds a BGP community, another one, and also you can check that and filter it out and do not accept the announcement. This is how you can do remote peering. And again, to summarize the strategy, at home you want to peer with as many networks as you can at your home IXP, in this example Frankfurt. At remote IXPs on other continents, in other countries, you only want to peer with networks which are local to the remote IXP. And you can use the DE-CIX route server for that and BGP communities. Also, you can use direct peering at the remote IXP. You can peer with networks who are not connected to the route server. Simply make sure that they are local to that IXP. Either ask them or look it up on a database like PeeringDB. Yeah, recommendation, simply ask them where they are located. And peer with them only at their or at your home IXP. And another question which often comes up, what about big networks who are basically local to every IXP in the world? And my recommendation is here, peer with them only at your home IXP. Otherwise, you would risk, in case of a maintenance or in case of an outage, that traffic to these high volume big networks goes via a way which you do not want. And in case you have a failure, you can always use your transit provider as a backup. And that's it. Thank you for listening. I'm Wolfgang Tremmel from the DE-CIX Academy. Thank you, happy peering, and bye-bye.